All right, we're going to start with our fundamental trig identities, chapter 5. I think I'm legally required to identify these as the fundamental trig identities. So what is an identity? If we think about what our identity is as a human, it's who we are. And so identities in trig are telling us what these functions are. We'll start with the first ones that we know and love, the reciprocal identities. And those are that functions like cosecant would really be 1 over sine. Secant of theta is really 1 over cosine of theta. Cotangent is really 1 over tangent. And all of these are the ones that we think about mostly, but we could also say in the other order that, like, sine, let's say, is 1 over cosecant, or cosine is 1 over secant, or that tangent is 1 over cotangent. Really just that these are our reciprocal functions that are related in that way. Then we have the quotient identities, which are also ones that you guys know. The first one is that tangent is really the ratio of sine over cosine, and that would mean that cotangent is, which is the reciprocal of tangent, cosine over sine. So everything on this page is hopefully not anything too shocking because we've been kind of dealing with these for pretty much as long as we've looked at these trig functions. The next identities are known as the Pythagorean identities. And if we think for a moment about our unit circle, we remember that any triangle on this unit circle has a radius of 1. Well, the unit circle has a radius of 1, which means this triangle has a hypotenuse of 1. Any point on this circle is the point cosine of that angle, sine of that angle, which means then that the x value is cosine and the y value is sine. Well, now look, I have a triangle. And Pythagorean theorem says that a squared plus b squared is equal to c squared. And if I take this triangle, I can use my trig functions to rewrite the Pythagorean theorem. Cosine theta squared plus sine theta squared is equal to 1 squared. And although that's a completely true statement, generally this is written as, well, I guess it doesn't really matter, but often we put sine first. I don't actually know why. Sine squared theta plus cosine squared theta is equal to 1. This is the first of our Pythagorean identities. Notice that this sine of theta squared is the same as sine squared theta. The reason we do this is because if I wrote it like this, sine of theta squared, I don't know if that's the angle measure squared or the sine of that angle measure squared. So just be careful on your notation there. Now this is the first of 3 Pythagorean identities. And to get the other 2, I am going to show you a little trick. So sine squared theta plus cosine squared theta is equal to 1. That is, like, honestly, if you don't listen to anything in the rest of this video, this is absolutely the most important right here. So please, please, please pay attention to that one. But there are some more Pythagorean identities, specifically if we take this function and divide it all by sine squared, let's say. If I divide one thing by sine squared theta, I have to divide all things by sine squared theta. Sine squared theta divided by sine squared theta is 1. Cosine over sine is cotangent, and 1 over sine is cosecant. So this is another version of our Pythagorean identities. It is the same, essentially, identity here. It's just been kind of transformed a bit. And now let's do that same thing that we just did, but instead of dividing everything by sine, what if we divided everything by cosine? So I'm dividing everything by cosine squared. Sine squared over cosine squared is tangent plus 1, because cosine over cosine is 1, and 1 over cosine is secant squared theta. And here is our third Pythagorean trig identity. Honestly, if you can remember this one, sine squared plus cosine squared equals 1, then we can get to these other two by doing that division I just showed you. In order to talk to you about our cofunction identities, I'm going to start by a really quick sketch of the first quadrant. Oh gosh, first quadrant of our unit circle. Let's try that again. That's better. So we've got the point square root of 3 over 2, 1/2, square root of 2 over 2, square root of 2 over 2, and then 1/2 square root of 3 over 2. Now I'm pointing out these points right here at 30 degrees and 60 degrees, because notice the sine of one is the cosine of the other, right? Sine of 30 degrees is 1/2, and that's the same as cosine of 60 degrees. And I could go and say that same thing about cosine of 30 degrees is square root of 3 over 2, which is the same as sine of 60 degrees. But what do we notice about 30 degrees and 60 degrees? And maybe you're like, I don't notice anything. These two functions, or excuse me, these two angles are complementary. And that, my friends, is the basis for our cofunction identities. This will be true across the board, that if I have two angles that are complementary, remember complementary means add up to 90 degrees, then sine of one will be equal to cosine of the other. So sine of theta is equal to cosine of pi over 2 minus theta. Oh no, I'm using pi over 2, not 90 degrees. Well, think of it like pi over 2, right, is right here, 90 degrees. Sine of 30 is equal to cosine of 90 minus 30, which is 60. We could continue by saying these cofunctions are true for all of the pairs, not all of the pairs, but some of the pairs in our 6 trig functions. So I could also say cosecant of some angle is equal to secant of pi over 2 minus that angle. Or I could say cotangent of some angle is equal to tangent of pi over 2 minus that angle. Notice again, this angle and that angle are complementary, add up to 90. And we could switch this. I'm not going to write it for all three, I don't think, because it would be the same, but I could make it tangent of theta is equal to cotangent of pi over 2 minus theta. It's the same idea. And of course, I could also change those all to 90 degrees, but I like using radians because they are more unfamiliar to us and we need as much practice as we can get. The last type of trig identities that we are starting with is even and odd functions. So think back, hopefully you remember, even means we are symmetric to the y-axis, right, like an x squared, and odd means we are symmetric to the origin. So if I consider my two main trig functions, which one is even, which one is odd? Well, the function that is symmetric to the y-axis is cosine, and the function that is symmetric to the origin is sine. And this gives us our even and odd identities. If I first consider even, let's say, so let's look at this function right here. If I plug in this x value, I get out this y value right here. And if I plug in this negative x value, I get that same y value. So that means cosine of negative theta will be equal to cosine of theta. If I plug in this angle measure, this x value, I get out the same y as I do as if I plug in a negative version of that. And if cosine is even, hopefully it's not shocking that secant is also even. My two even functions. Sine then is odd, which if I look at my graph and I consider what that means, I am seeing that when I plug in this x value, I get out this y up here. And if I plug in the opposite of that x value, I'm getting the opposite y value. So to be odd means sine of negative theta is equal to negative sine of theta. These are technically the same things we had before, right? F of negative x is equal to negative f of x if a function is odd. We're just adding these into our trig functions now. If sine is odd, that means cosecant is also odd. Oops, negative cosecant of theta. And tangent and cotangent are also odd. If you think about the graph of tangent, it is symmetric to the origin. So there are our even and odd identities. So the last thing that I want to talk about is some general tips and tricks for solving and simplifying trig equations. And we're going to do a lot of examples when we get to class, but I want to give you this information just right off the bat. These are not in any specific order, but I am going to number them just because that's how my brain is working. So the first one is, again, this is not a step-by-step process, these are just hints. But one suggestion is to change all functions to sine and cosine if possible, right? If I have tangent of theta times, let's say, cosine of theta. Well, instead of writing tangent, tangent I really know is sine over cosine. And now, notice these cosines cancel, and I'm left with just sine of theta. This is the type of thing we're going to be doing. It's kind of a puzzle. It's starting with one thing and trying to get to another. So that's hint number one. Change all functions to sine and cosine if possible. Sometimes it helps, sometimes it doesn't, and that's okay. Next tip is to, I wanted that to be blue, I'll change it in a second. Look for quadratic equations. Look for quadratic equations. What the heck do I mean by that? Well, sometimes they are going to hide a quadratic using trig functions. And how might that look? Well, let's say I have something that looks like this. Secant squared theta plus 2 secant theta plus 1. I could really see that as x squared plus 2x plus 1, where x is secant of theta. And this, in the blue, is a lot easier to solve, right? Because we're used to solving quadratics. We're not so keen on solving secant, cosecant, etc. Another tip for you is to factor out like terms. Factor out like terms. But if we are solving, we don't actually want to cancel. So I'm going to make a small note. If solving, don't cancel. And I will kind of bring that up when we do an example like it in class. But if I had something like x cubed plus 2x is equal to 0, you would all know, oh, I factor out an x. I'm left with x squared plus 2 is equal to 0. I set this equal to 0 and this equal to 0 and solve. It's exactly the same idea whether we're using the variable x or our trig functions. And the last little hint I have is to convert any non-basic, convert any, I'm going to put this in quotes because it's not really mathy, any non-basic trig identities to something more basic. So when I'm talking about non-basic, I'm talking about those co-function or even and odd. If you ever see something that starts as a co-function, or you see something with the even and odd feeling, I would just change that right away. And again, I will remind you what this means when we do some examples in class. All right, that was a lot. Have a great weekend.